Lesson 36, Writing and Solving Proportions. Jump into our new concepts today. Proportions are frequently used to solve problems in mathematics. Proportional reasoning can be applied in many situations, including reading and drawing maps, architectural, and construction. Solving problems in these situations requires a knowledge of similar figures. If two geometric objects or figures are similar, they both have the same shape but are not necessarily the same size. The triangles below are said to be similar. So here you have the description: triangle ABC is, with this little squiggly line, similar to triangle DEF. When two figures are similar, they have sides and angles that correspond. Corresponding sides and angles are found using the order of the letters in the similarity statement. In triangles above, A and D are corresponding. So if they're in the same kind of direction, proportion to each other in these corners, corresponding are B and E, and then F and C. Corresponding angles of similar figures are congruent, or they have the same measurement. So angle D and angle A are exactly the same. Angle B and angle E are exactly the same. Angle F and angle C are exactly the same. Sides of similar figures also correspond. Obviously, you can tell, however, they're not the same length. In the example above, A and B corresponds to D and E. B and C corresponds to E and F. A and C corresponds to D and F. Corresponding sides of similar figures do not have to be congruent. However, they do have to have proportion. The ratio of them in pairs of corresponding sides must be the same. So if you compared A and B to D and E, it's going to be proportional to B and C and E and F, meaning that because this is 2 times larger, so 1 times 2 is 2, and this is going to be 2 times larger. 2 times 2 is 4. Triangle ABC is 2 times larger than triangle DEF. All of those measurements for the corresponding sides are actually twice the size. In the example above, the ratio of the sides of triangle ABC to DEF is 2 to 1. The ratio, which can be written as 2 to 1 or 2 to 1, is called the scale factor for triangles ABC and DEF. So this is twice as large just based on the size of those sides. And you'll notice that when you're identifying the side lengths for those proportions, you're using the same fraction for the same side, but the different triangle. So here A and B was in the numerator, D and E was in the denominator, but you're talking about the same side, the congruent side or similar side, therefore you're putting that in the same fraction in comparison to a different side that is going to have that same type of comparison. Okay? A scale factor is the ratio of a side length of a figure to the side length of a similar figure. The scale factor of DEF to ABC is 1 to 2, or it's 2 times larger. In example 1, we're going to apply what we kind of just discussed. Finding measures in similar figures. You've got PQRS is similar to WXYZ. These two shapes are similar. You can tell that all of the angles then are congruent, meaning they're the exact same length or same degree measurement, but the sides are different lengths because they're bigger, one's larger than the other. If we look at the solution here, Q and X correspond, so they are equal. If the angle of Q is 80, then the angle of X, if the angle of X is 80, then the angle of Q is 80. If the angle of P is 120, then the angle of W is 120 because they're corresponding angles. If the angle of R is 70, then the angle of Y must be 70. B, find the scale factor of PQRS to WXYZ. Here you're going to take those side lengths and compare them. Here you've got PS is comparable to WZ, so you're going to put that into a fraction. This is the length of 3 over 2, and it's written right here. To find the scale factor, then, you're going to try and reduce this, and you can't reduce this anymore, so the scale factor is 3 to 2. Use the scale factor to find QR and ZY. Here's where we're going to put into practice something that we've learned previously that is going to come back and be really useful for us. That's if something's missing in a proportion, you're going to solve by cross-multiplying and dividing. Here, when you're finding QR, which is a missing value A, and comparing it to XY, you know that XY is 5. So here it's going to be written out as A is the missing value, the large number in the numerator, and 5 is the known value, is compared to two of the other known values that you have. So PS is 3 and WZ is 2. We use that as our scale factor here, 3 over 2, and we're going to compare that to the fraction of A for QR and 5 for XY. So 3/2 is compared to what over 5? Cross multiply, divide, or use your multiplication. How do you get from 3 to what is equal to 2 times something to 5. So 3 times 5 is 15 divided by 2 is 7.5. I use the cross multiply divide method because that's going to be something that you're familiar with in order to solve that scale factor. So if A is 7.5, then you have your measurements for 3, 6, 7.5. You maybe need to find, if it asks you, PQ, what this is based on something that you also have as a known value. In this example here, ZY is an unknown value B, but you do know that SR is 6. So they set up the equation again to say that the known value that we have for PS and WZ is 3 over 2. So that's our known scale factor. And they're going to take 6 as the numerator because it's the larger fraction here, put that there, and B as the missing value here. Again, you're going to cross multiply and divide. 2 times 6 is 12, divided by 3 is 4 to find your missing value. Okay, so you've got to be able to set up this proportion, this comparison of sides with the side lengths, and then just use your math, cross multiplying, dividing, to solve for that missing value. Example 2, using indirect measurement. A radio tower casts a shadow 10 feet long. A woman who is 5.5 feet tall casts a shadow 4 feet long. The triangle drawn with the tower and its shadow is similar to the triangle drawn with the woman and her shadow. How tall is the radio tower? So you have two known values for the woman's height and the length of her shadow. You don't know what the radio tower height is, but you do know the length of the shadow. Because you know the length of that shadow, you can create a proportion with those two values. Here's the example. 10 is compared to 4. So they write that as a fraction. Now you're going to compare the other unknown value, x, which is the height of the tower versus the height of the woman. And you have now your proportion set up, and the proportion has a missing value, so you're going to cross multiply and divide. They multiply 10 times 5.5 to get 55, 4 times x to get 4x, and then they divide by 4 on both sides to give you your answer of 13.75. The radio tower is 13.75 feet tall. A scale drawing is a drawing that reduces or enlarges the dimensions of an object by a constant factor. Maps and blueprints are examples of scale drawings. The scale is a ratio showing the relationship between a scale drawing or a model and the actual object. A lot of times when we are using a scale drawing, you're saying this is this much larger or this much smaller than it would be in real life. When it's a scale drawing, a lot of times you're thinking that the drawing is smaller than what the actual blueprint is going to look like. In this example, a desk is designed to have 3 drawers on the right side. In the scale design drawing, the width of the drawer is 4 centimeters. If the scale of the drawing is 1 centimeter equals 4 centimeters, how will you find the actual desk, how wide will the actual desk drawers be? So you set a proportion to what you know. One proportion is 1 to 7, and then the known value of the smaller value of the drawing is 4 over something. So 1/7 equals 4 over what the actual is going to be. Cross multiply divide. 7 times 4 is 27, divided by 1 is 28. 7 times 4 is 28. So your value of the actual desk drawer is going to be 28 centimeters wide. In our exploration, you're going to find out that there's this relationship when it comes to proportions between finding perimeter or measurements and area and volume. Now, you've probably already seen this before because each time that Mr. Shane tells you to write units when it comes to area or volume, he's trying to hammer home the idea that you need to write squared for something that is area and cubed for something that is volume. If you would go through and complete this exploration, you'd find that the length of something, when it's in a proportion, can be simply calculated by using our cross multiply and divide. But in this example, letter A says begin with 1 cube and let the length equal 1. Then the perimeter of the base of the cube is 4 times 1. So if you've got a cube and you measured its length and one of those measurements is equal to 1, you would have the perimeter 1 plus 1 plus 1 plus 1 is 4. Then the area would be 1 times 1, which is 1, and the volume would be 1 times 1 times 1, which is 1. Now, that doesn't really work with the length of something being 1 because anything multiplied by 1 is going to be obviously itself. But there's a ratio that happens when you do that with 2. Now, it said that you're supposed to work in partners, and we would normally do this in person, but we're just going to kind of do this with our minds right now. For letter B, it says use the cubes to build another cube with the edge length of 2 units. So if you've got a cube, a square, that has 2 units by 2 units, you're going to think about how this perimeter is going to be a little bit different. You're going to have 2 by 2 by 2 by 2, so it's going to be 8 here. The area then would be 2 times 2, which is 4, and the volume, which would be 2 times 2 times 2, which would be 8. You'll notice that it's increasing as it goes from area to volume. The edge length again for something with a length of 3 on the sides, the perimeter would be 3 plus 3 plus 3 plus 3. The area would be 3 times 3, and the volume would be 3 times 3 times 3. So this would be 9 and 27. You'll notice that every time you go from area, you are squaring that unit, and when you go to volume, you are cubing that unit because you're now multiplying by those factors. The rule is written right here, the ratios for perimeter, area, and volume of similar figures. If two similar figures have a scale factor of AB, then the ratio of their perimeters is AB. Perimeter is calculated simply by the length, and the ratio is going to be calculated by the scale factor. If you're calculating ratio of area, you have to do it twice because there's two units that you're calculating, length times width. If you're calculating volume, you have to do it 3 times, that's why it's cubed. It's length times width times height. So the ratio for area is a squared over b squared. The ratio for volume is a cubed over b cubed. Here's an example in example 4. The application is changing dimensions. A dartboard is composed of concentric circles. The radius of the smallest inner circle is 1 inch, and with each consecutive circle, the radius increases by 1. What is the ratio of the circumference of the two inner circles to the circumference of the outermost circle? Well, here, when you're talking about the circumference of the circle, you're using a scale factor for the just overall length of that. Here, this is 1, this would then be 2, this would then be 3, this would then be 4, this would then be 5. For your radius, to find the circumference, you're going to multiply 2 times pi times the radius, and you're going to have a comparison here where 2 times pi times 2 versus 2 times pi times 5, those are going to cancel out, and you're going to have just 2/5 as the difference between the ratio of the circumference of the innermost circle versus the circumference of the outermost circle. Now, when you go to area, we just mentioned that the area makes it double because you're going to multiply and square by both of those factors. Here's an example. So just by length, we had a comparison of the inner two circles of 2 to the 5 on the outside. When you're thinking of the ratio of the area of the two circles, you have 2 times pi squared, and then you have 5 times pi squared, because now you're factoring in the area of the circle, which turns into 4 pi over 25 pi. The pi's would cancel, so you get 4/25. Notice it, what you do here, 2 times 2, or 2 squared, equals 4. 5 times 5, or 5 squared, equals 25. So the rule that we just learned about here, that when you're talking about just perimeter or measurement, your ratio factor doesn't change, but when you go to area, you square each of those measurements, you square your scale factor to find that new calculation for area. That shows itself right here in example 4. Take a look at our lesson practice problems. In letter A, it says triangle ABC is similar to or congruent to LKM. Find the measurement of K and C. Now here I want to find where I have those congruent angles. So B and K are the same, A and L are the same, and M and C are the same. Therefore, I'm going to know that if M is 20, C is 20. If I know that B is 25, I know that K is 25 because they're in the same orientation in terms of the shape, and then they have that angle that looks exactly the same. Those are going to be the corresponding angles, so you can know, if you know it in one of the triangles, you know it in the other triangle. In letter B, the figures are similar. Find the scale factor, then use the scale factor to find x. Well, to find the scale factor, you're going to take what you know and compare it to the corresponding sides on the other triangle. So in this example for letter B, the scale factor is 5 on one side in comparison to 3 on the corresponding or similar other side. So 5 to 3, right? Because these are both the vertical standing up sides with the right angle here. 5 to 3 is our scale factor. Now we're going to use that as our ratio, our proportion, and compare it to the other values that we don't know. So 5 over 3 is compared to x over 5. We have a missing variable, so we're going to use cross multiply and divide. 5 times 5 is 25. So this is going to be equal to 25. 5 is compared to 25 as 3 is compared to 5 on this side. Our missing value for, sorry, that's not right. 5 times 5 is 25. 25 divided by 3 is going to be your answer for x. Our scale factor is 25 to 3. Is 5 to 3. This would be 25 divided by 3, which is going to be, you can write it as 25 thirds, or you can calculate it out what that's actually going to be in a decimal. Letter C. The side of a building casts a shadow 21 meters long. A statue that is 5 meters tall casts a shadow 4 meters long. The triangles are similar. How tall is the building? Here you take your scale factor. X is compared to 5 as 21 is compared to 4, and do your calculation. You would cross multiply. X is compared to 5 as 21 is compared to 4. So you'd have X times 4 and 21 times 5. 21 times 5 is going to give you 84 divided by 4, which gets you a total of 26.25 meters for your overall height. So you have to simply set this up with those two proportions. Again, X over 5, 21 over 4. Cross multiply to find your X value. Letter D. The scale drawing of the kitchen tabletop has dimensions 5 inches by 2.5 inches. If the scale factor of the drawing to the actual table is 1 inches to 18 inches, what are the dimensions of the actual table? So you take the scale factor of 1 inch to 18 inches, and you can compare that to each of the dimensions of the table. So the scale drawing of the kitchen tabletop has 5 by 2.5. You're going to take 5 multiplied by 18 and 2.5 and multiply by 18 to increase what that actual is going to be. 5 times 18 is going to give you 90. 2.5 times 18 is going to give you 45 as your overall dimensions. 90 inches by 45 inches. Letter E. Small toy cars are constructed using a scale factor of 1 inch to 64 inches. What is the ratio of the areas of the toy car and the actual car? For the dimensions of the actual car, it's 1 to 64. Then you have to take and square those to get to the area. So 1 times 1, 1 squared is 1. What is 64 times 64? Figure that out. You'd have 1 inch to 4,096 square inches because the area is always squared when it comes to our scale factor. Hope that helps you complete your practice problems for today. If you have any questions, feel free to reach out. God's blessings.